Students, let us continue with Unit 4 videos, and as we are in compression topic, in previous video we have seen dictionary compression. Now let us continue with the posting compression. Now first of all, let us we revise what do you mean by posting. So what posting is containing? Containing all the document IDs in which the particular term is present. Okay, so posting is taking more memory than depression. So the compression technique is more necessary for posting than dictionary. So compression technique will be more useful for posting than dictionary. Okay. So what the statement here they are telling is posting file is much larger than dictionary with a factor of at least 10, because what the dictionary is containing only the terms, but what the posting is containing IDs of all the documents in which the term is present. Now what happens, that term may exist in n number of documents, so all those n number of document IDs I should store in posting. Okay, so every ID is considered as one posting, so such n number of postings will be there, so automatically your posting file memory requirement is more. That's why the memory requirement, if you want to reduce, go for the compression technique. Okay, so what is the key consideration? We want to store the posting compactly by applying compression on it. Okay, now let us consider we are having nearly 8 lakhs of documents. Okay, and for every document ID, how many bits I am requiring? 32 bits. 32 bit means what? It is a 4 byte integer. Okay, now when I apply, instead of going for this direct multiplication, what I am going to do here, I am applying at least a log. Okay, then in that case, instead of 32 bits, the memory requirement will be reduced to 20 bits. Okay, so this is a very simple compression technique, and here what is our goal is, now even I want to reduce memory requirement even less than that 20 bits I want to go. Okay, now for that purpose what compression techniques we can apply. So here you should keep in mind there are two factors. Okay, first possibility is what, your term may appear in n number of documents, and another possibility is what, your term may appear only in one or two document. For example, see the term here, arachnocentric. Okay, so that will happen in what, only in one document out of the millions of the document. Okay, then in that case, if I am applying a log on that 1 million, and for each document I am using 20 bits, then in that case this memory will be wasted. This is one point. Now another point is what, a term like the. Actually, when you are going for the steaming operation, when you are removing your stop words, actually you will remove that the. But when I am trying to represent the in the posting forms, then it will appear nearly in every document. Then in that case, even these 20 bits are not sufficient for me. My memory requirement is increasing. So in every case, the frequency does matter. Based on the frequency of your document only, memory requirement will be considered. Okay, so when for the term the, I am using 20 bits per posting, then it is too expensive for me, because in every document the will exist and those many 20 bits I need to use. Okay, so the first technique is what, using the gap between the document IDs. Now what I am doing, suppose my term is computer, it is occurring in these 5 documents. Okay, now these are the IDs of all those 5 documents. Now what I am doing, instead of storing the ID of a next document, I am trying to find out the gap between the previous document and next document. So subtract the 47 from means 33 must be subtracted from 47. Then what is the difference? 14. So instead of storing 47, what I am storing? 14. What I am storing? 14. Okay. Now here instead of storing 154, the difference between the 154 and 47, that is 107 I am storing. Now here the next two are with less gap. So I need to store only the value 5. Now here you can observe the advantage of instead of recording the document ID directly, when you store the gap, how your memory requirement is reduced. Now here I need to store the two values which are very nearby. Okay, now instead of storing the value as 159, if I store the gap as 5, then the memory required to store 5 is very less. So that is the main advantage I will get when I am storing the gap. But as you can observe, when this technique will be useful, when the gaps between the document is less, then only this technique will be useful. If the gap between the document is more, then it will not give me that much memory difference. Okay. So here what we are doing, we are trying to encode the gaps, and we hope that that gap can be encoded in fewer than 20 bits. Okay, that we can hope. And when we can hope this one, when the term is found in nearby documents, when the difference between the two document ID is less, so that gap will have the less value. So that less value I can represent with the less number of the bits. And when this compression technique will be useful, if I can represent the gap with less number of the bits than 20 bits, then only this compression technique is useful to me. Okay. Now here you can see a detailed example, D. Now here you will observe, listen, D is present nearly in every document. That's why what is the gap that you are going to store? 1111, because it is found in every document. Now the next one is what? Computer. Now computer is found in first document with the ID ending at 47, and the next ID is ending at 154. So what is the gap here? 107 that you are storing. But this is also okay, because you are getting the advantage. How you are getting? Instead of 6-bit value, you are getting only the 3-bit value. So you can represent it with the less number of the bits than the 20 bits. Okay. Then here the most important advantage you are finding is only the 5 document ID is the difference, and here you are having only the difference of 43. Okay. Now the next one, the rare term. Okay, that is what archenocentric. Now here, how is the gap? You observe, the first document in which it is existing is given here. Then what is the next document which is in the range of nearly 5 lakhs? Okay, so what is my gap? Nearly it is having the gap of 2,48,100 documents. Okay, these many document gap is there. Okay, so which one is better here? Better I don't use the gap technique here. Better I go for storing directly document ID. And here later on the term is not at all existing. So though I am storing the direct document ID and though I am storing the gap, the memory requirement is same. So for such rare terms, memory requirement is not changed. It is not reduced. So for rare terms, this compression technique is not useful. The compression technique is useful for those terms which are occurring in every document nearly, or in the documents with the less difference. Okay. Now, one second. Now, as I told you, in the archinometric, we want less than 20 bits per gap entry. Okay. Now here, if you want to use this gap to reduce your memory requirement, then find out a term G. Okay, that is representing the average gap. Okay, for every term. So here, what is the key challenge is, we want to represent gap with the fewer number of the bits, so that my memory requirement is reduced, means fewer number of the bits as needed for that integer. So here I am trying to use the variable length encoding. So in variable length encoding, what I am trying to do is, here you will understand that if the term is present in the next document, means that is a continuation document. If the term is present in next document, then my gap value will be what? 1. So that will be considered as a continuation document. Then in that case, what I will try to do, if you are using G bits to represent your gap, then in that G bit I will use one bit to represent that it is a continuation of the document. Okay, means the gap between the two document is one. That to represent that one, I'm not using all your 20 bits for that gap. I'm using only one bit, and that bit will be called as a continuation bit. Now how I will do? Listen, in 1 byte there are 8 bits. Out of 8, 7 I will use to encode my G, the gap. But when that gap is equal to 1, then in that case I will use only the last bit, that is the continuation bit, and that I am setting to 1. Okay, so the gap is represented by 8 bits. So the lower order 7 bits are used to represent the gap, while the additional bit is used to encode whether it is in the continuation of the document ID. Okay. So here when your C is equal to 1 means it is a immediately next document. When C is equal to 0 means what? It is not immediately next document. This is one of the technique that you can use. Now here, see what is my document ID here? 824 and 829. Now 824 I am representing by this code. Okay. Now 829 I am representing by this code. Now this is the gap that I am observing. Now what is the gap between the second and the third ID? There is a huge gap. Still, to represent that huge gap, I can use my G, which is of 8 bits. So after applying this, I am getting this code. Okay. Now what I will do? I will combine these all codes together like this. Okay. So this is what called as a variable length encoding. Okay. The posting is stored as a whatever is your G byte na, that you using for representing the gap, I will concatenate all those G bytes together. So I will get a variable length encoding. So what is a variable length encoding main property? That it is having a uniquely prefix decodable. Okay, that is having a uniquely prefix decodable. Yes. But what is the main disadvantage that they are observing? That here I am having the gap of only one value. Okay, that is what? A 5. But here I am demanding for whole byte. So that you can consider as a disadvantage of this variable length encoding. Now other unit codes. Now what I am doing here? Instead of bytes, we can also use a different unit of the alignment, in which 32 bits, 16 bits or 4 bits I can use. So how I am going to use it? Okay. Now here represent the n as n ones with a final 0. Okay. So how I am going to represent the 3 ones with the final 0. Okay. So whenever there will be 5 ones with final 0. So 40 ones and like this. But here what is the disadvantage? How the value here increasing, those many ones are increasing. Okay. So this is not that much effective compression technique. Okay. Now the next third technique is what? Gamma codes. In gamma codes, what I am trying to do, it is a bit level coding, in which I am going to store a pair of length and offset. Now for example 13 you are going to suppose represent with the 1101. Then I will cut the leading bit. I will get the 101 only. Now what is the length of this 101? 3. Okay. And when you are trying to encode the 3, how you can encode the 3? Represent the 3 number of ones and the last bit is 0. Now what is your encoded value? 101. And how you are going to represent that length with this one? Now combine both of it, 1110 and then 101. combine this both, okay, and that is what called as a gamma code. So in the same way you will get the gamma code of different values by combining the length and the offset, okay. So what is the use of this gamma code is with the factor of 2 the memory requirement is reduced as compared to your G. That is the first technique. And the next one is what gamma code is also having a unique prefix like your VB, okay. So these are the comparisons of all of our compression techniques which we have used for the dictionary as well as the posting. So this is all about the posting compression, in which we have seen the first one how we can use the byte G, then how we can use the variable length encoding, and the next one was the gamma coding. So these are all the compression techniques, and this is what the summary of it. In the table whatever is given, how your memory requirement is reduced, that is stated here, okay. So thank you.